I'm Rodney Brooks. I'm on my sixth AI and robotics startup over the last 41 years. This one is Robust.AI, and we put robots into warehouses to help the human pickers. I think it's a bit of a myth to think we're just going to magically reshore US manufacturing, because you need the supply chain. What we can reshore right now, because the supply chain is fairly sophisticated but at the same time simple, is silicon fab, and that's getting reshored right now. Silicon fab is happening at scale. More complex electromechanical devices with lots of chips in them, it's really hard to compete with the supply chains that have been in China for 30 years, and now we see them in Malaysia. It's hard to build those whole supply chains quickly. It will take 20 years of dedicated work to do it. It's not a simple tariff is going to change everything. Human-robot collaboration has gotten a whole lot better recently for a whole number of reasons. The first is because we can have so much onboard computation now, because GPUs have become really, really cheap, and the low-end chips that wouldn't make it into the server farms, you can still do stuff one-on-one and recognize in the image what's happening, through the eyes of the robot, what the person's doing. You can recognize with the neural models, you can recognize their body posture, how they're moving. You can process their speech. We couldn't do that 10, 15 years ago. That was hard to capture and get reliable, especially in a noisy environment. This happens to be a noisy environment where I'm doing this. So all that lets us get more information about the person and what they're doing. And actuators have gotten cheaper, so we can actuate the robot. Besides having a screen for a face, but it turns out psychological studies show that a physical avatar physically moves is better perceived by people to be cooperative. Deploying software at scale is sort of easy because you don't have to make another copy of the software. It's just a copy operation. To make another copy of a robot means you need a supply chain, and it maybe have components which may take 3 months to get. You need more. You need 100 more of them or 1,000 more of them. That could be a 3-month wait. So you got to manage the supply chain, and you have to manage the number of robots you're building so that you don't have to have enormous warehouses full of expensive robots that aren't doing anything. So there's a whole management issue for deploying robots that doesn't exist for straight AI programs. But then deploying at scale, the robot has to give the buyer some return on investment. And typically, there are 3 buyers. There's the corporate buyer, there's the management of the facility where the robot is going to be used, and there's the workers in that environment. And if the workers don't like the robots, bad things are going to happen. You can go into a lot of hospitals that have robots to take the dirty sheets and the dirty dishes from the floor down below, and they're all pushed off to the side. And you ask the nurses, why are they pushed off to the side, switched off? They say, oh, it broke. What that means is the robot got in the way when they were doing something critical thing with the patient, moving the patient, and the robot didn't know what to do, so it just stopped and blocked them. And it really made the nurses angry. Get that thing out of me. So you have to make it a return on investment for all 3. The people who are working there, the management of the site, and the corporate entity. And you have to show return on investment. Someone's got to want the thing that your robot does for you. They're not going to buy more than 1 or 2 of them just because it's a robot. They might do that to say, wow, we're forward looking. We got a humanoid robot in our place, but it's not doing anything. To do it at scale, it's got to provide real value to all 3 of those buyers. A naive view of robots is you're just making them move in particular ways. But in fact, if you want a robot to do anything, it's got to touch stuff. Otherwise, it's not doing much, except maybe talking to you. It's got to touch stuff. That means you have to apply forces in the world somewhere. When you apply a force, there's resistance. When you're pushing harder, you're putting more energy, kinetic energy into your robot. If something goes wrong, you have to pull that kinetic energy out, or you have to dissipate the kinetic energy anyway. So it's about energy management, especially if you want the robot operating near people. You better make it safe. And if it's got a lot of kinetic energy, you don't want that robot to be out, fall over and have its legs trying to balance, kick someone. You have to have a very much a layered approach of perceiving what's around. It's using AI, perceiving what's around, deciding how much energy is safe to have in your robot right now, and then be aware of when your sensing maybe isn't very accurate, so you preemptively pull out some of the kinetic energy ahead of time. Now, in our robots that we have in warehouses, they're wheeled. That makes them simpler. But there's a manual mode where you can grab the robot and it amplifies the force you're applying and goes faster. We make it so that when you push forward, it accelerates at a reasonable level so it doesn't scare people nearby. But when you pull back, we decelerate really fast because that means the human saw something and they wanted that robot to stop. So the AI has to make inferences about what's happening and control the kinetic energy. I like being at these conferences so I can talk to people who are actually building things and actually trying to sell them, and then get the reality, what their real challenges are that they may not say out in public because everything's rosy. But, if you talk to them carefully, you can find out where the pain points are. Where's my biggest pain point in deploying my robots? It's the IT guy. No, you can't put your robot on my Wi-Fi. You cannot. And, once you know that, you know that your job when you get there is to really work with the IT guy because he's your biggest barrier. So you'll find out stuff like that. Who are the big barriers to adoption? And so that's what excites me about things like the AI conference. One of the things about an event with lots of people from lots of different companies is, everyone's been focusing on their thing, and then they see this other thing over here. Oh, we had that problem. Maybe that piece helps this piece. And so it enables people to put things together. Now, whether they go and buy it from them or whether they go and build their own is a whole different question, but it does push the whole field forward.